All right, so continuing where we left off, we are now going to derive the even and odd identities. And so over here, if I have some angle theta, right? Again, this is assuming this is part of the unit circle. The x coordinate, you already know, is cosine of theta. The y value is sine of theta. And if I ask you, hey, what is this angle right here? Well, instead of calling this positive theta, I'm going to call this negative theta. And you would say, hey, this is cosine of negative theta, and this is sine of negative theta. Okay, so a couple of observations that you can make, right? Clearly, these two x values are the same. So your first trig identity, right, you could say cosine of negative theta is same thing as cosine of theta, right? So again, if this is phi 3, this is phi negative 3, right? These x values are the same. If I ask you, what's another observation you can make? You could say, hey, this y value is the negative of this y value. Okay, negative 3 is the negative of this 3. Okay, and then as far as tangent goes, you could say tangent of negative theta using your quotient identity is the sine of negative theta over the cosine of negative theta. Sine of negative theta is just negative sine theta. Cosine of negative theta is just cosine of theta, right? Just using these two identities that we just derived. Well, what's sine over cosine? That's tangent. And these, and this is how you derive your even and odd identities, okay? The very last set of identities that we have to derive, you can write them in 1, 2, 3 in any order you like, are the cofunction identities, okay? And these ones we're just going to observe drawing a right triangle. So if I have a right triangle over here, I'll call this triangle ABC, and let me call angle A, I'll call it theta. If I ask you, what is the sine of theta, you would say that's opposite over hypotenuse. That's BC over AB. If this is 90 and this is theta, right, and the sum of the measure of triangle apt to 180, angle C in terms of theta would just be 180 minus 90 minus theta, which will just give you 90 minus theta. Okay, I mean, you could do the math, right? This plus 90, that should give you 180. Okay, so we said sine of theta is BC over AB. Another way of obtaining this ratio is, what if I said, what is the cosine of 90 minus theta? And you would say that's also BC over AB, right? Okay, so one of your cofunction identities, right, is you could say sine of theta is the same thing as cosine of 90 minus theta, right? Or if I ask you, hey, what is the sine of 90 minus theta? The sine of 90 minus theta, right, is AB over AC. And what is the cosine of theta? The cosine of theta is also AB over AC, right? And so you can see that these two values are the same, right? So you can say sine of 90 minus theta is the same thing as cosine of theta. Oops. Okay, and so your cofunction identities are essentially just by observation. Okay, so from this right triangle. So over here, right, you can list them all out. I'm just going to list them all out here for you. I believe your textbook uses radians instead of degrees, which is fine. Okay, so sine of theta, we said, was cosine of 90 minus theta. You could use pi over 2 over here. It doesn't really matter. In this case, depends on the context of the problem. You could say cosine of theta, right, is the sine of 90 minus theta. Right, and then tan is the cotan of 90 minus theta. Okay, and this is also true, right? If you take the sine of 90 minus theta, which is the same as cosine of 90 minus theta, right, which we already have over here. You could say cotan of theta is the same thing as the tan of 90 minus theta. You could say the secant of theta is the same thing as the cosecant of 90 minus theta. Or you could say the cosecant of 90 minus theta is the same thing as secant. Or sorry, I should have said secant of 90 minus theta is the same thing as cosecant of 90 minus theta. Okay, there should be a 90 right here. Okay, so this one I already listed out twice, so I don't have to say this again. So 1, 2, 3, 4, 5, 6. There's technically 6 cofunction identities, and you can do this all just by observation. Okay, so I'm just going to do one problem here on this first page, and then we'll go over to the back of the notes. Okay, so this is just a review problem, right? You're given one trig ratio. You're told basically what angle your theta is in, or what quadrant it is in, and you're asked to find the other 5 trig functions of theta. Okay, so this is again review, right? So they tell you that cosecant theta is -5. Cosecant theta, we said, is the reciprocal identity of sine, right? 1 over sine is cosecant, and sine is y over r. Cosecant is r over y. You may want to bring this negative down right here, right? 5 over -1 is r over y. And the way I showed you how to do this in class, right? We're told that theta is in quadrant number 3, is to draw the right triangle. So here is my theta. And the way you sketch the triangle here in quadrant number 3 is like this, right? Our r, which is our hypotenuse, can never be negative. And that's why I brought this negative down here, right? Y is -1. And if you want to solve for x, right, call that x. And then once you have x, you can figure out all 5 remaining trig ratios. Okay, so quickly solve using Pythagorean theorem. Okay, you're going to get x is the square root of 24, which is 4 times 6, which is 2 root 6. Okay, so this 2 root 6 right here should be negative because I'm in quadrant number 3. So you have -2 root 6 as your x, and -1 as your y, and then 5 as your r. Okay, so let's list out the remaining 5 trig ratios, right? So sine of theta is really the reciprocal of cosecant. So the reciprocal of -5 is -1/5. Cosine of theta is x over r, -2 root 6 over 5. Tangent of theta is y over x, right? -1 over -2 root 6 is +1 over 2 root 6. And if you rationalize the denominator, you're going to get root 6. Multiply top and bottom by root 6. Root 6 times root 6 is just 6. 6 times 2 is 12. And we said, let's see, cosecant theta, we already said, is given to us in the problem. Cosine of theta, right, the reciprocal of cosine is secant. So secant of theta is just the reciprocal of this, which is 5 over -2 root 6. And if you multiply top and bottom by root 6 over here, you're going to get 5 root 6. Root 6 times root 6 again is just 6. 6 times -2 is -12. And our very last one, of course, is cotan, right? Cotan would just be the reciprocal of this, which is 2 root 6 over 1. Okay. All right, so this is just a little review on, finding your 5 other trig functions, depending on, what trig function they give you, and then what quadrant theta is in.